Alright guys, let's look at example 3 in our calculation question of equilibrium constant. I said that for equilibrium to occur, the rate of forward reaction must be equal to the rate of reverse reaction, right? And we said calculate the equilibrium constant for the reversible reaction of this, right? First of all, I said the step 1 of this, step 1, we must check for balanced equation. We must check if the equation is balanced. Balanced equation. Alright, so let's check if the equation is balanced. We have 1 ion here, but we have 3 ion here. So what do? We simply put a 3 mole here, so 3 Fe is balanced, right? We have 4 oxygen here, but then we have just 1 here, so I can put 4 here. So I have 4 oxygen, but then I have 8 hydrogen, 4 times 2 giving me 8 hydrogen, but 4 oxygen. This is 4 oxygen, right? So what do I do to this? I can simply put 4 here, so I have 4 times 2, 8. The equation now is balanced. So we have 3 ion, 4 hydrogen, 4 oxygen, 3 ion, 4 oxygen, 8 hydrogen, right? So from here, having done that, we state the formula, right? But to state the formula, we said for equilibrium constant, that's Kc, it is equal to the what? The concentration of the product, right? To the concentration of the what? Of the reactant. That's what it is. And what are the products here? These are the products. Right, these are our products, and as well as these being our reactants. So let's get them off. It's going to be the concentration of Fe3O4, right, times the concentration of what? H2, right? But then the coefficient there, we have 4 here, so H is going to be 4 here. There's nothing here, there's no coefficient here, so that's why we don't have anything here, right? Over what? Over, let's check for the reactant, we have Fe3, so we have Fe, but then the coefficient is 3, so we have 3 here, times that for hydrogen, H2O, but then if you check, we have 4 here, right? Having done that, they gave us value for everything, right? Value for ion is 0.28 molar, so let's fit in the value. It becomes, what's the value for ion tetrasulfate? 6. We have 0.56 raised to the power of nothing, right? Times the one for the hydrogen gas, that's H2, is 0.32 molar raised to the power of what? 4. So we have 4 here. All over, let's check for Fe. Ion is 0.28. Now 0.28. Is there anything here raised to the power of 3 is? And then times for the hydrogen, the water there, or the gas there, H2O is 0.36. 36 raised to the power of 4. This is the best time to use that calculator of yours, right? So with that, we have our Kc equal to 0.56 times, if we take the fourth root, that's 0.32 raised to the power of 4, we're going to get 0.01048,576. 0.01048,576 over what do we have? 0.28 raised to the power of 3. What are we going to have? We're going to have 0.021952. Sorry, 0.021952 times 0.36 raised to the power of 4. We're going to get 0.01679616. 0.01679616. That's what we're going to get, right? Having done that, if you take the product of the numerator, I'm going to have 0.0058720, so on and so forth. 0.005872, so on and so forth, right? If we divide it by the denominator, what we're going to have, we take the product, if we multiply that, we'll have 0.000366870. 0.0003668, sorry, 36870. I believe so. I hope my calculator is not failing me. Yes. And so if we divide both, we're going to have 15.9. If we divide both, we're going to have 15.9. That's our answer for the constant. Of course, you know that constant does not have there are no units to that. Alright, so that's the answer. Therefore, we can now say that our Kc is equal to 15.9. That's the answer to this question on the board. So just look at it, just familiarize yourself with it, try and practice them, you see how it works. I'll see you in the next video, guys. Thank you. Question number 4 says nitrogen reacts with chlorine. Nitrogen is a gas. So N2 said N2 react with chlorine, Cl2. They're all gases, right? To produce nitrogen trichloride, right? It produces since we know we are doing a reversible reaction to produce nitrogen trichloride, NCl3, that's what aqueous, right? Nitrogen trichloride. At equilibrium, the concentration of each gas were found to be those are their value to find the equilibrium constant for the reaction. In this case, we know it's not balanced, right? Just by looking at this, it's not balanced. So how do we balance this? We have 2 nitrogen here, so what I'm going to put 2 here, right? So I know that nitrogen is balanced, but then chlorine is not balanced because 2 times 3 gives me 6. Then I have 2, so what I have to put here is 3. Finally, it's balanced, right? So what do I do? Look at this: 2 nitrogen, 6 chlorine, 2 nitrogen, 6 chlorine. I told you I have a complete video on this. So let's continue. What do? We know that our equilibrium constant, our Kp, becomes the concentration of product, right, over the concentration of what? Reactant, right? That's what we're going to get. So for the product, what do we have for the product? For the product, we have our nitrogen trichloride, our NCl3, but then we have a coefficient which is 2 here, the mole, right? Over for our reactants, what do we have? For reactants, we have N2. So we have N2, and then what? We have chlorine here, but we have a coefficient of 3. So we have Cl2, then we have 3 here. So we'll start fixing the value. Very simple, very easy. So the value, what do we have? For nitrogen trichloride, we got 0.52. So we don't need this again. The concentration 0.52 all raised to the power of 2. Right, over for nitrogen, what do we have for nitrogen? 0.26. Right, we have 0.26 for nitrogen, and then for chlorine, what do we have? 0.12. We have 0.12 raised to the power of what? 3. Right, so let's try. If we do 0.52, if we take the square of 0.52, what are we going to get? We're going to have 0.2704. Right, yeah, we're going to have 0.2704. That's what we're going to have. And let's take the product of this. We're going to have 0.26. We have 0.26 times, we take the cube of 0.12. What are we going to have? We're going to have 0.001728. 0.001728. Right? So by doing that, we know that our Kp is going to be 0.2704 over, if we take the product of that, what we're going to get 0.26 times 0.001728, we're going to have 0.040928. 0.00044928. If we do that, our Kp, take the quotient of that, we're going to have 601.85. 601.85, approximately 602. So our answer, very simple. Just look at it, see how easy it gets, right? Follow the steps, see how easy it gets. Next video, I'll drop one video on the board, try it and leave your answer in the comment section. That way we'll know we're even. I'll see you in the next video, guys.